Today we're just doing section 4.5. We're going to be in this section for quite some time. The focus is graphing trig functions, and we're going to focus just on sine today. This is something that you learned a little bit in Algebra 2, and we're going to kind of elaborate on what we've learned last year. So first thing we're going to write down is the general procedure on how to graph the sine wave. So I would just label this the graphing sine. So the general form is y equals, I don't know why it's doing that right there, y equals a sine of bx minus c. And one thing I want you to take note of is that c has a minus sign, so whenever I ask for the c value, you're technically taking the opposite sign of it. So things that are important is the amplitude, and we find the amplitude by our a value. So the amplitude is our a value, and the amplitude represents the height of the wave. So this is the height of the wave. So essentially the amplitude determines the highest and the lowest point of the wave. The next thing that we find is the starting point. And it doesn't matter the order in which we calculate these. So the starting point is calculated by taking c value divided by b value. So notice I just put a c up here. And in the original equation, it says a negative c. So you always have to take the opposite value of your c. The reason we have a starting point is the sine wave will travel forever and left to right. So the domain is all reals because it's going to go forever and ever and ever. We're just going to be focusing in on one individual wave. So we need to know where that one particular wave is starting. That's how you find the starting point. The next is the period. And the period is calculated by taking 2 pi and dividing it by b. And once you do 2 pi divided by b, the period represents the distance for one wave to be completed. So it's the distance for one wave to be completed. So I'm going to have to switch on to another screen. So if you don't have this all copied, please pause the video right now and copy this. I'm going to just move on to the next screen. So after we find the amplitude, starting point, and period, the next thing we find is the 5x values. So my x1 value is always your starting point. I'm just going to abbreviate that as starting point. And in terms of sine, it's always, your first value is always your x-intercept. Your second value is either a max or a min, and that is based on the amplitude value. Your x3 value is an intercept. Your x4 value is a min-max. And again, this is based off of your amplitude. That's how you know if you're going to a max or a min first. And x5, you finish on an x-intercept. So the next question you're probably thinking is, well, how do I find all of these x values? So you calculated the starting point in that very first calculation by doing c divided by b. So c divided by b will always be, whatever that result is, will always be your x1 value. To find the next values, you have to take that period that you calculated, so that the period's 2 pi over b. So whatever you get for your period, we have to divide that answer by 4. The reason we divide it by 4 is notice that there's 4 coordinates or 4 x values left over after I have a starting point. So I need to make sure that these spots are equally spaced out. this period over 4 is what I use to add to get from the first to the second to the third to the fourth value and so on. And then it'll make a little bit more sense when we do an example. So we're going to get right into it, and we're going to try graphing one and going through this procedure. I'm warning you right now, it's a very long process, so please bear with me. We're going to begin today by just doing the basic standard sine function. So we are going to graph a y equals sine of x. So first thing I want to discuss is that x could be there or theta could be there. They could go interchangeable. Next thing I want to discuss is what is a, b, and c. So before we actually get into any of the problem, we need to decide what is my a value, what is my b value, and what is my c value. So a is the coefficient of sine. So it essentially means how many sines are there. So when we look at this problem, notice there's one sine. It's just we don't write the number 1. So technically there's one sine. So my a is 1. Similarly, your b value is always the coefficient in front of your x or theta, whichever the problem is using. So notice I have 1x. And I could technically write minus 0 here, and my c value would now be 0. So key thing to remember is that a is always in front of sine, b is in front of x, c is that second term hanging off the end. C is always opposite. So my amplitude is 1. My starting point is c divided by b. So my c value is 0 divided by 1. This will be 0. My period is 2 pi over b. And we've established that the b value is 1. So I'm doing 2 pi divided by 1. So the period's going to remain 2 pi. And the last thing we find is my period over 4. So I'm going to take whatever I got in that problem prior, which was 2 pi, and I divide that answer by 4. So I get a pi over 2. This is what we're going to be adding to those x coordinates in a moment. So now that we've figured out all of these basics, next thing we have to find is our x coordinates. So remember, your x1 value is always your starting point. So my starting point in this case is 0. It will not always start at 0. The moment you have a c value, you've now shifted away and you're not starting at 0. What we're adding each time is pi over 2. So 0 plus pi over 2 would be pi over 2. I'm going to add another pi over 2 to that. So when I add another pi over 2 to pi over 2, I get 2 pi over 2, which is just pi. If I add another pi over 2 to that, now I'm at 3 pi over 2. And lastly, I am at 4 pi over 2. And that would be 2 pi. Now notice the distance from my starting point to my ending point is 2 pi, and that should match up with what my period is. So the wave needs to be completed from 0 to 2 pi. So on the next screen, we're going to get all this information on a graph. So I'm going to switch the screen to a graph. Go ahead and take a moment and draw a graph in your notes. So we're going to let's do the medium. So we're going to draw our xy axis. You're going to kind of skew it a little. The focus is going to be in the positive x values. So the amplitude is 1, so let's go by halves just so we can kind of see everything. So we'll assume that's 1, and this is a negative 1. And the period started at 0 and it ends at 2 pi. So we just need to make sure it's equal spaced. And we don't have to use itty-bitty dots, but you want to just make sure it's equal spaced. So let's say here's half pi, there's pi, there's 3 pi over 2, and here's 2 pi. So notice I kind of spread it out equal distance. So here's 2 pi, there's a pi, so we know this is a half pi, and this is a 3 pi over 2. So now I need to just get all this information onto the graph. So my first x1 value is 0, and if you go back to that list, remember your x1 value is an intercept. So I'm going to start at an intercept at 0. Then I go to my x2 value, which is pi over 2, and then that list that we originally made, it said it's either a min or a max. So the way we determine that is our amplitude. Our amplitude was a positive 1. So that means we go to a positive 1 first. Your third value is an intercept. The fourth value says min-max. Well, since I went to a max first, that means now I go to the min. And your fifth value is an intercept. So we end right here. So here is a sine wave. Notice this is just one wave. Again, this will go on forever. So if I did another wave, it would continue on, and it would continue in this direction also. So the sine wave goes forever. We just focused in on one period of the sine wave. So that's all for today. We're going to do some more examples tomorrow.